Well, hey guys, so this is going to be our notes for what is the velocity lesson. And if we look at the agenda in the right-hand corner, we see that the first thing we're going to do is look at this warm-up question. Second thing we're going to do is we're going to look at what velocity is mathematically. And this third thing we're going to do is we're going to look at some mathematical practice of velocity and kind of using some variables. And then we're just going to have some final thoughts. So our warm-up question here, what we're going to do is we're going to look at I'm just going to read through it, and then we'll figure out the answer. So warm-up question: how are vectors represented in physics problems? Are they a circle, B, an arrow, or C, a square? When we look at vector problems, let's see if I can get my pencil up. When we look at vector problems in physics, we are looking at using arrows. So there we go, nice and easy. So we're always going to represent it with an arrow, and then we will represent it with, usually on the top, we end up having our units and the amount. So even if, let's say if that's 10 meters per second, and we wanted to, we had a car go faster, maybe 100 meters per second, we're going to end up having a longer arrow, and we'll end up putting 100 meters per second, and there you go. So moving on to the next slide here. Our objective for the lesson is that by the end of taking notes, we should be able to define velocity, describe velocity in different situations, and solve math velocity equations. Or math velocity problems using velocity equations. So here's some notes that you can see from your workbook here. I'm just going to read through it, and then we'll answer the question. So from the previous lesson, we know that speed is how fast an object is, but what if we wanted to note the direction the object is making? So that's very important. Direction the object is making. This is what we call velocity. How fast an object is and the direction that it is going in. Velocity is what we call in physics a vector quantity, a quantity that specifies the direction and magnitude of an object. Now I bring up this at direction and magnitude. Magnitude is amount, and direction, we are talking about, our north, south, west, and east. East here. We're talking about our compass rose. So what is velocity? A vector quantity. We'll just end up saying that. So a vector quantity. Magnitude, which is again amount, and direction. Okay. Moving on. Next thing here. So if an object moves from one place to another, from the VI to VF, VI stands for initial velocity, the VF stands for final velocity, we call this displacement. Displacement is change in position. So just like when we talked about speed, speed we said was a change in displacement. Now displacement is a change in position. So we use the following equation to find displacement. That would be the change in velocity is equal to V final minus V initial. So you're just looking for the final one subtracted by the initial one, you'll end up getting your displacement. So an example of displacement, let's say if a car travels from 20 miles per hour to 100 miles per hour, okay, we end up getting, it would be our 100, let's see if I can get this going. Displacement, change in V minus VF minus VI. We're going to end up having change in 100 minus 20. So you always have your final minus your initial. We'd end up having 80 miles per hour. So displacement for this car is 80 miles per hour. If we look from a car going from 90 miles per hour to 10 miles per hour, now we end up seeing that it would be here 90 minus 10. And we end up having 10 being the final, 90 minus 90 miles per hour being the initial, and we get a negative number. Now this brings up a good point here, that when we end up having velocities can be negative numbers. And let me read through our text here to stay on tracks with our reading. When we look at velocity, we have to understand that velocity is the displacement of an object divided by the time interval. This can be a negative number or a positive number depending on the sign of displacement. We use the following equation. And let me get our equation up. So V stands for velocity again. V average is equal to the change in distance, x being the distance in the horizontal form, yeah. So V final minus initial, and then T stands for time. So the triangle here, this triangle, I want to, if I can bring this up, this triangle here, actually this is good, this stands for change. So change in x, change in t, we have to find the displacement between them. Now, I also want to show something on the right here. Actually, let me use this here. This guy here, all of this here, that is for that if your car is going, or the object, I just say car because we just saw a car, if your object is going in this direction, it's going to be negative. If it's going in this direction, it's going to be positive. So let's go through a problem and let's see what we can do using our average velocity equation. Now, just a key thing is that Western Avenue is the longest, Western Avenue in Chicago, Western Avenue right here, is the longest avenue in the whole entire United States. It is 32 kilometers long, and let's just say, read through the problem, you're traveling to a store that is 32 kilometers down Western Avenue. So you went all the way south to all the way north. You had to turn around and go back 15 kilometers before you passed up the store. It takes you 2 hours to get there. What is your average velocity? Well, first, let's write out our equation. Let's figure out the numbers to which variables they're going to be, and then let's solve. So our average equation here, so let me end up using, I'll use black here. So V average is equal to change in x over change in t, right? And then we have x final minus x initial divided by t final minus t initial. Okay, so now our x final is going to be, if you had to turn around, so the first, you had a store that is 32 kilometers down Western Avenue. So our x final is going to be 32 kilometers. Oh, you know what? Let me make this a different color. We'll use purple. So x here. So we have our x final is going to be 32 kilometers. That's where you're going to end up. Okay, you had to turn around and go back. So our initial. So our initial is going to be 15 meters. Okay, so our t final is going to be 2 hours. I should be using the seconds instead of minutes. We want to use always the SI units. And then our TI is equal to 0 hours because that's where we started from. Alright, so let's figure this out. So we have V average is equal to change in x divided by change in t, and then we have our final here. So we have our 32 meters minus our 15 meters divided by our 2 hours minus our 0 hours. Okay, so 32 minus 15 is 15. So I'm going to actually bring our math all the way up to here. So we're going to have 15 meters divided by 2 hours. So 15 divided by 2 hours here, we get 7 equals 7.5 meters per hour. That's going to be our answer. Yep. Okay, going on to our next one. A plane is traveling from Chicago to New York. Its initial velocity is 120 meters per second east, and it traveled east for 1.5 hours. Then it travels 1.5 meters per second north for 1 hour. What is the average velocity of the plane traveling to New York? Okay, this is interesting here. Now, because we are using direction, we need to use direction too. So what we're going to end up doing is, let me draw this out first. So we have it traveling east. Now let me end up making a compass rose up here. So let me do it again. So if we go north, south, east, and west. Now the next thing I'm going to do is I'm going to draw a line going east for us, and 120 meters per second east, 120 meters per second east, okay? And then it traveled east for 1.5 hours, okay? And then it traveled north here for, oh, you know what? I want to take that back here. You know what I'm going to do first is I want to find the velocity of each. So I'm going to draw that arrow. So first thing I'm going to do is I'm going to do velocities 120 meters per second divided by velocity is equal to, let me find the velocity of both first. So v is equal to change in x, change in t, 120 meters per second. And then the next one, we got our time, 1.5 hours. So if I do that on the calculator, 120. We got 80. Since we have different units there, we have to leave it that. So this is going to be 80 meters per second / hours. Okay, and then the next one here, sorry about that. I know I'm kind of going backwards now. So we got that. Now that, because we have only 1 hour, we're going to have it just where it's going to be 150 meters per hour. Okay, so we have that now. So we have an east and a north. Now, to find the relationship between these two, what we are going to have to do is we're going to have to use the Pythagorean theorem. We're going to have an A and a B, and we're going to be looking for C. So that is going to be, should put it here, 80 meters per second hours squared plus, I'm going to run out of room here, plus 150 meters per second / hours squared, and that's going to be equal to our c squared. Now, if I do this, I'm just going to do this on a separate sheet of paper so I can have enough room for that. So if I do 180 squared, 180 squared, 32400 plus my 150 squared, 22500. I add those two together, and then I square root 32400 plus 22500 equals, okay, and then I square root that guy, second, and square root. Where is the square root at? Second and square root. I get 234. I get C is equal to 234. Now, if you need some help with this guy, I totally get it, and I'll help you out when we have Pythagorean theorem problems. So going on from there, our final thoughts complete the velocity reading, read through those scalars, what a scalar is, what a quantity vector is, and work on some problems, and I will help you through that. All right, any questions, let me know, and good luck.